Welcome to Akbar Academy. Today we are tackling a question involving electrical power, resistance and cost calculations for using an electric heater. This question will help us apply Ohm's law, resistance formulas and energy cost calculations. Let's break this down step by step. Part A. Calculating the current in the resistance wire. We are given power dissipated in the wire equals 2,500 watts. Resistance of the wire equals 26 ohms. We need to calculate the current I. Using the power formula, power equals current squared multiplied by resistance. This formula is derived from Ohm's law and the basic power equation in electrical circuits. Ohm's law states that voltage equals current multiplied by resistance. Power can also be expressed as current multiplied by voltage. Substituting voltage from Ohm's law into the power equation gives us power equals current multiplied by resistance multiplied by current, which simplifies to power equals current squared multiplied by resistance. This equation helps us determine the power dissipated in a resistive component based on its resistance and current. Rearrange for current. Current equals square root of power divided by resistance. Substituting the values. Current equals square root of 2,500 divided by 26, which equals 9.805807 amperes, approximately 9.8 amperes. Final answer 9.8 amps. Part B. Calculating the resistance of the new wire. We are given initial resistance R1 equals 26 ohms. Initial length L1 equals 1.2 meters. Initial cross-sectional area A1 equals 7.9 times 10 to the negative 7th square meters. New length L2 equals 1.8 meters. New cross-sectional area A2 equals 5.8 times 10 to the negative 7th square meters. We need to calculate the new resistance R2 using the resistance formula. Resistance equals resistivity multiplied by length divided by area, and since resistivity remains constant, R1 equals K multiplied by L1 divided by A1. To solve for K, K equals R, 1 multiplied by A1, then divided by L1. K equals 26 multiplied by 7.9 times 10 to the negative 7th, divided by 1.2, which equals 1.711667 times 10 to the power of negative 5. This constant K represents the material's resistivity properties. We need to calculate K first because it allows us to determine the resistance of the new wire without knowing the resistivity directly. Since the material remains the same, its resistivity is a constant factor, making K useful for comparing different wire dimensions. Now using K to find R2, R2 equals K multiplied by L2 divided by A2. Substituting the values, R2 equals 1.71116667 times 10 to the power of negative 5 multiplied by 1.8 divided by 5.8 times 10 to the power of negative 7, which equals 53.12069 ohms, approximately 53 ohms. Final answer, 53 ohms. Part C. Understanding the cost of running the heater for 2 days. Imagine leaving a heater running continuously for 2 days. How much would that cost? Let's find out. We are given power of the heater equals 2,500 watts. Electricity cost equals $0.30 per kilowatt hour. Time of operation equals 2 days. Let's go step by step. Convert power to kilowatts. A heater with a power of 2,500 watts is equivalent to power in kilowatts equals power in watts divided by 1,000. 2,500 divided by 1,000 equals 2.5 kilowatts. Convert time to hours. Since we are running the heater for 2 full days, time in hours equals 2 days multiplied by 24 hours per day, giving us 48 hours. Calculate the energy consumption. Energy in kilowatt hours equals power in kilowatts multiplied by time in hours. 2.5 kilowatts times 48 hours equals 120 kilowatt hours. Calculate the total cost. Now let's see how much this costs based on the electricity price. Total cost equals energy in kilowatt hours multiplied by cost per kilowatt hour. 120 kilowatt hours times $0.30 per kilowatt hour equals $36. So running this heater continuously for 2 days would cost $36. This is a practical example of how understanding power consumption can help manage electricity bills effectively. Final answer, $36. Thank you for joining us at Akbar Academy. Keep practicing, stay curious, and see you in the next lesson.